This is lecture 16 of CS47 Computer Organization Study. In this lecture, we'll look at the logic circuit design with an example. And of course, we will confine ourselves into discussing combinational logic circuit design only. In CS147 computer architecture class though, we'll continue with the circuit design aspect, both combinational and sequential circuit design. There are a couple of steps for logic circuit design. Like, let's discuss them with respect to combinational circuit design. First of all, write the specification. This is like no-brainer. This is done for any engineering project. To go to customers, talk with them, then write the specification of the target system. It's in the software design, it's in the hardware design, it's in electronic design, it's in a civil design, it's in civil architecture design, it's in mechanical design. Write specification is a standard step. And then from that specification, we need to formulate the function or the problem in terms of truth table. Once we formulate it, then we pick up this truth table and optimize the Boolean function into the reduced form, like most optimized reduced Boolean expression for the function, and map the function into available logic gate. What does it mean? Like, let's say your Boolean function comes about with and, or, not Boolean functions, maybe XOR is involved, XNOR is involved. Now let's say to implement that logic function, you do not have all the type of gates. Let's say in your library you have only NAND gate, or you have only NAND and inverter, or you have only NAND NOR inverter. So you are limited with your resources, that how many different type of hardwares you can use. So from the optimized Boolean expression, you need to translate or transform that expression with the available logic functions. Let's say, just simplest example, let's say you have only NAND logic circuit, NAND gate at your hand in your library. Okay. So, and you come up with a Boolean function. So what you need to do from that Boolean function, you need to transform that function in terms of all NAND operation. And you can well imagine what you need to deploy there. De Morgan's transformation, De Morgan rules that you'll apply onto that expression and make it a NAND only function. Similar goes for the NOR only. Then once we're done, of course, we need to draw the logic circuit and everything. Schematic diagram we'll see. So last part is to verify the logic circuit. Let's say we come up with a logic. Now we test it with respect to different combination of possible inputs and observe if they are working correctly as part the specification says. Okay.